We now talk about Black and Scholes call and put option pricing. So we start with an example. So first, notice that there are a large number of softwares in the market. There are Excel plugins which will just simply help you compute call and put prices if you use them as a black box. And later on in this lecture, we will actually come to the actual formula of call and put option. So for right now, consider an example. So say the underlying stock price, so spot price today is 45. The volatility of the stock price or the underlying is 20% and you determine strike to be 50. R is risk-free rate is 0.05%. So this risk-free rate is generally the interest rate on the government bonds. Now we also have to determine the expiration date. So say expiration date is 3 months from now. So we put tau as the time to expiration. So say this is 3 months. So you put these 5 things into the formula. One is the spot price today. Second is the volatility. Third is the strike. Fourth is the risk-free rate. And fifth is the time till expiration date. So if you plug these 5 things into the formula or into your software, it will spit out a call option value and a put option value. So call option value would be 0.356 and put option value would be 5.349. So if your spot price is in dollars, your strike price is in dollars, then obviously call value and put value would be in dollars. Now you can keep changing the strike price. So we keep spot price, volatility, risk-free rate and tau as constant, and we continue changing this strike price. If you continue changing the strike price, you can construct an option ladder. So at strike price of 35, call is 10.012, put is 0.008. Strike of 40, call is 5.252, put is 0.247, and so on. So you can continue changing strike and you will get different prices for call and put. So this can be done with the help of large number of softwares. So this is just a black box of finding the prices of call and put. And say if you have a strangle or a straddle, then you find out the price for individual call and individual put, which are part of straddle or strangle, and then you sum them up to get the total money you have to spend to get that position. So let us now come to the ingredients of this Black-Scholes formula. The call option price is given as, this call option is equal to ND1 times S. S is the spot price minus ND2 times K, which is the strike price, exponential of minus R tau. R is the risk-free rate and tau is the time to maturity. So in our example, time to maturity was say 3 months. Or you can say time to expiration date. So N of D is the cumulative distribution function of the standard normal. And you can compute it numerically as minus infinity to D 1 over square root of 2 pi exponential of minus half x square. Again, tau is the time to maturity or time till expiration date. S is the spot price of the underlying. K is the strike price of the underlying. Sigma is the volatility. This we will use in a minute. R is the risk-free rate. So this is generally for interest paid on government bonds. Now this D1 right here, you can write D1 as 1 over sigma square root of tau log of S by K plus R plus sigma square by 2 tau. So quite a bit formula, and then D2 is D1 minus sigma root of tau. So you compute D1, you compute D2, then you compute ND1, ND2, you plug in ND1 here, you plug in ND2 here, and you get the call option price. And for the put call parity, gives us the put option price. So put is equal to call minus the spot price plus strike times exponential of minus risk-free rate times tau. So this is quite a mouthful, and generally unless you're doing mathematical finance, you do not worry about the underlying details. You can just use a software and that will give you the call and put prices. The most important ingredient of call and put prices is volatility. You can't do anything about the spot price it is given to you. You can't do anything about the risk-free rate. Once you determine the time to maturity and the strike price, everything is set. But you can think about volatility. So volatility of the underlying comes from the data of the underlying spot prices. So what data you should use? So should you use last 20 years of data to compute volatility, or last 10 years of data, or last 10 days of data, or last 1 day of data? So you have to make a judgment call. Ideally, you should use a short range. You should not use 20 years or 10 years, because if the market is very volatile, then this large time span essentially gives a wrong price. So it is a judgment call on how many days you will use for computation of volatility. And this is extremely important. In fact, almost all the trading or profit making position rests on the interpretation of the volatility of the market.